Hello again. So we are going to continue today talking about world famous land formations and how they were created. Okay, so we have been researching how various land formations all over the world, how they came to be. We've been looking into the type of boundary, like the plate boundary, that interacted with each other and created this land formation. So you have oceanic crust interacting with an oceanic crust, and you'll have oceanic crust interacting with continental crust, and then continental crust interacting with continental crust. And all of these interactions are going to be the reason that we have some of these famous land formations, because those types of crusts will interact in three ways. They'll either slide or transform, they'll divide, which is called the divergent boundary, or they'll collide, which is called the convergent boundary. So within these slides, you'll see a picture of the world famous land formation, and you'll either see an example of another example from the world, another famous land formation of the same type, or you'll see a different diagram or map of the same location. And then on your own time, you are to look through all of the videos. The videos are short, and they kind of give you a tour and some background information on the creation of these land formations. So in my last video, we already discussed the Great African Rift Valley, which is a divergent boundary. We also already discussed Japan, which in its uniqueness is a convergent boundary. We also discussed the Himalayan mountains, which is a convergent boundary. This is where Mount Everest is found. And then we lastly talked about the Aleutian Islands off the coast of Alaska and how this convergent boundary formed these very exciting and volatile islands. Today, in the second video, we're going to talk about the Andes Mountains. So these mountains are found on the west coast of South America. And they're very, very tall. It's a very long mountain range. It's one of the longest mountain ranges in the world. It follows the entire coast of South America. Right here you have a picture of the Andes Mountains with their very sharp, jagged peaks and edges on the coast of South America. Another example I was able to find, these are coastal mountains found along the North American coast, as far as like Northern California all the way up through Alaska and Canada. I just called them the Pacific Coastal Mountains. You also have the Cascade Mountains, but they are very, very similar to the Andes Mountains in that they are formed from oceanic crust and continental crust, and they are convergent, meaning that the ocean crust is colliding with a continental crust. And in this video, what you can see in this bottom video is it demonstrates what happens when oceanic crust, which is very dense, collides with continental crust, which is not as dense. The oceanic crust sinks below the continental crust, and it recycles the oceanic crust back into magma, and that pushes up, creating that volcano. And you'll also find that a trench is created at that subduction zone where the plates meet. And then the top video is really just talking about how magnificent the Andes Mountains are, how rich and diverse in animal and plant species. It's very diverse climate-wise because it's such a long mountain range. The Andes Mountains, it affects so much around it in South America, like the Amazon River and the Amazon rainforest. So it's very interesting and dynamic land formation. The next land formation we're going to talk about is right here in America. This is the San Andreas Fault, and this is located in Southern California. So you can see in this first picture, you see that it looks like a bunch of hills, maybe some mountains, but really that is just where the land has been grinding against each other. So on one side you have a plate and on the other you have a tectonic plate. And they're going in opposite directions. One's moving up and one's moving down, so to speak. One of the reasons the San Andreas Fault is so famous is because it's one of the only faults that we can see. It's above ground. And it's basically this huge line of sheared continental crust where the land formation basically grinded against each other. And what happens is they usually grind very slowly. They move very slow so that they build up a lot of tension and force. And so then when they do move more, that's what initiates our more severe earthquakes. And historically, San Andreas hasn't had an earthquake, a major earthquake, in quite some time, but the last one was very devastating. And in this video, he talks about how devastating it would have been had it happened today with the populated areas like Los Angeles, who will be affected by the next earthquake, major earthquake that the San Andreas Fault has. Another example of a fault line right here is the Alpine Fault in New Zealand. And New Zealand's very mountainous and it's obviously very green, whereas in California you see a lot of desert. But this is again where two continental plates are sliding next to each other with a lot of force and a lot of tension, and they have a lot of major earthquakes in this area due to that. And then I have another video that's got some interesting aerial and drone footage of the San Andreas Fault. It is quite a remarkable sight. Lastly, we have Iceland. And I highly encourage you guys to explore Iceland some more. It's a really interesting island. It's actually the largest volcanic island, and it's over 20 million years old. And it sits on a divergent boundary. So you have the North American plate going to the left, and the Eurasian plate going to the right. And this division goes all the way through down to the Atlantic Ocean, past the east coast of South America. It's a very large boundary where these two plates are separating. And so Iceland is essentially being pulled in half. It's highly volcanic. There's a ton of volcanoes. Due to when you have a divergent boundary, magma is pushed up through the divide, through that break in the crust, and that's where you get your volcanic mountains. Iceland has a giant rift, so in this first image you can see where that divergent boundary is pulling Iceland apart, and you see that in this rift valley. And so what I have written here is, like, when two tectonic plates are dividing, the division on land creates a rift valley, and the division in the ocean, on the ocean floor, creates an ocean ridge. So that's why you see Mid-Atlantic Ridge, because that's an underwater mountain range that resulted from this divergent boundary. But on Iceland, because it's land, it is going to create a rift valley. So the divergent boundary on that Iceland sits on top of has created the rift valley. It's got some really interesting volcanic history. This video shows really beautiful landscapes and waterfalls and gives you a little bit of a history of Iceland. And I also have some drone footage of following the rift. And as you can see, it's very different than a fault line. The fault looks somewhat like a rift, but it's a lot smaller. The rift is huge. It's a giant valley with cliffs and things of that nature.